Hello class, and welcome to Unit 4. Unit 4 is only going to be about 4 or 5 lessons, and it's a transitional unit. It's going to get us to introduce quadratic functions, mostly using a graphing calculator, or you could use any online graphing calculator or calculator app. But what we're going to do is just introduce what quadratic functions are, compare them to other type of functions, and then we're going to take a look at transformations within quadratics, how you shift the parabola left, right, up, down, stretch it, compress it, reflect it, which means to flip it upside down. But to start with, we're just going to introduce some of the technology. So if already you have a note at the beginning of your notebook that's just for graphing calculator or TID3 notes, please pull them out and we're going to add this stuff to it. If not, just put it in your regular notes, okay? I will remind you that Unit 4 is very short since it's only 4 lessons. We will not be having a unit test just for Unit 4. We will combine it in with Units 5 and 6 when we get into the algebra behind quadratics and the applications within quadratics. Okay, so just note on the website it should probably say this is a small unit and we won't have a specific Unit 4 test. All right, so let's get started here. If you happen to have a graphing calculator or a calculator app at home, please feel free to jump to one and do some graphing with it and have some fun. Okay, but in order to do a lot of these questions, I actually have to use the graphing calculator because the graphing calculator has a menu screen which will help you answer some of these things. And I'm just using this to introduce the concept of a quadratic and how we see it in real life applications. All right, let's start at the top. So we're graphing and analyzing quadratic relations using the TI-83. If by chance you have an Android cell phone, ladies and gentlemen, you can get a free download app on your phone, which will be the TI-83 calculator, which I'm going to use. So that's kind of cool. Let's take a look here. Number 1, reset calculators and set to 2 decimal places. Again, I have those buttons listed on a sheet in my classroom. For those who aren't sure, I will go show you it in a minute when I get to the graphing calculator. Then what we're going to do is press y equals to graph. So that's where we're going to enter in the equation. And remember that y is already there, so y1, y2, y3, etc. And we're going to use xt theta n button for the independent variable of x. So wherever we see x in our equation, we're going to use that xt theta n button. And you may need to change your window or adjust your window to get a good graph. All right, once we get our equation in the graphing calculator, the good thing is there's a calculate menu on your graphing calculator. And to get to your calculating menu, you press second and trace, and you should see that it says calc. And I'll show you that when we get there. And the menu shows 5 items that we're going to focus today. One is the value button, and that's the dependent. You can find the dependent variable by substituting in the independent variable. The 0 finds what's called the x-intercepts, and you're going to do a left bound, right bound for each of those. The minimum value finds the vertex when the parabola opens up. So remember we talked earlier about parabolas, and if it opens up, the vertex is going to be at the bottom. That's the case for a minimum. And number 4, the maximum finds the vertex when the parabola opens down. Okay, so that's when it's an upside down or a flipped parabola, and we find the maximum. Okay, and the last one is intersect, and that's the point of intersection. Okay, P of I. So notice how we did point of intersections just with linear systems. We're going to do points of intersection with a parabola and a line, so it's going to be kind of cool. All right, so ladies and gentlemen, I want you to take a look at our first example, and then we'll get into the graphing calculator. A rocket is shot giving the equation h equals negative 4.9 t squared plus 72 t. So instead of x's in this case, we've got t, because t represents times in seconds, and h represents the height. Okay? And so what we're figuring out, folks, is we've got some, if we're taking a look at xy, or in our case, time and height. Okay, the rocket's going to get shot. It's going to come to a maximum height, and then it's going to shut back down. I want you to visualize that. Okay, and I'll show it to you when we do the calculations. So I apologize for having to flip back and forth, but we're going to go to the graphing calculator. I'm going to do the reset button, so I'm going to go second function plus sign 722. It should say default set. I'm going to go second function plus sign 4, enter. It's going to say done. Okay, I'm then going to go to y equals and make sure I have no equations in there. If I do, I press clear down arrow, etc. Okay, and then it says I want to set my mode to 2 decimal places. So mode, go down to float, and over to 2 decimal places. Okay, and again, if you have a Android phone, you can actually get this app for free and do it with me. All right, so I've got that set. Now, ladies and gentlemen, let's take a look at our word problem. We need to enter the equation in y equals, so I press the y equals button, and it says the equation is negative 4.9. Just remember, guys, negative is the one that's in the brackets here, not the subtract sign. So negative 4.9 x t theta n x squared, because it's can't do t squared, so you got to do x t theta n squared plus 72x. Okay? And let's take a look what the graph looks like. Okay, so we see parts of it. The problem is we don't see enough of it. So that means we've got to adjust our window. So taking a look at x. X deals with our time in seconds. I'm not worried about negative seconds, so I'm going to go 0. Okay, and roughly how long do you think it takes for the rocket to get up in the air and down? I don't know, let's say 20 seconds. Okay, and again, this will adjust until we can figure it out. Minimum height, I'm not going to worry about negative height. And maximum height, I don't know, let's just say 300. Let's be generous with this. Okay, so now I'm going to press graph. And notice I've got a nice quadratic parabola there. Okay? All right, so that's the vision we want to do. Now, question 1 says, at what height did the rocket get shot? Okay, so if I flip back, I apologize, we're going to be doing this a little bit here. Okay, so at what height did the rocket get shot? Well, I want you to remember what the time is when the rocket got shot. When the rocket got shot, time equals 0. Okay, and so what you need to remember is that we're going to press the value button in our menu, and we're going to let the value of x equals 0, so x equals 0, and then we're going to find out what y equals. So let's go back to the calculator. Go see the menu, it says calc right above trace here, so go second trace. Okay. Sorry, let me put my pen down and try that again. Second trace. Haha. Give me a second. I've got an overlay map on here. Let me get the ink layer off. Sometimes technology doesn't always work for you. And now I lost my... I apologize, guys. Give me a minute. I somehow just lost my screen. Maybe if I plug it back up, it will... see if it'll come back up. Otherwise, this is a complete delay. Okay, I think we're okay. So let's try this again. Second trace. Okay, now we got that menu up. We want to press value, which is 1. We want to sub in x equals 0. Press enter, and what do you find out? That y equals 0. So see y equals 0 there? So I'm going to go back to my lesson. Type in y equals 0. What does that mean? The height is 0. So therefore, rocket was on the ground when launched. Okay? And what's really cool, folks, is if you haven't realized, this is a quadratic that's in what we call standard form. And there's no number by itself here, so it's really going to be plus 0. That automatically tells me that it shoots from the ground. All right, the next question. When did the rocket hit the ground? So at that point, I'm looking for this. When does it hit the ground down here? Okay, and that's an x-intercept. And another word for x-intercept in terms of our menu is looking for the 0. Okay, all right, so we're going to go back to our calculator. Go second, trace. Okay, I'm going to erase that other part here. Okay, and we need 0. So press 0, which is 2. Okay, now we need to focus on the correct 0. So I need, if I'm looking for this one, ladies and gentlemen, right here, I need to get, when it says left bound, right bound, I got to get my cursor over. So notice it's going to move all the way over. Come on, cursor, come on. So it's just to the left of it. Okay, that's too much now. Oh boy. Sorry. went too much of me. Okay, so see how it's on the left side of that 0 point? I press enter. Now I want to be on the right bound, so I have to make sure my y is negative. So I'm just going to move over. Seeing that the y's are negative now, that's okay. It'll say guess, press enter. So y equals 0, which means my height occurs at 0 when x equals 14.69. So what does that tell me? That 14.69 seconds, or at 14.9 seconds, the rocket hit the ground. Okay. All right, next one says, what was the maximum height of the rocket? Well, first of all, we're going to learn that you can tell by your quadratic if there's a negative out front. So the negative's out front, so it tells me it opens down, which tells me there's got to be a maximum value. So to do the maximum value, you're going to go to the menu and press the maximum button. And folks, this will get easier as we do a couple more examples. Okay. And so I go second trace, maximum is 4. It says left bound, right bound, so I got to get my cursor on the left bound of my vertex, which is the peak, right guys? Let's just see if it goes to the left side. Okay, stop. My calculator, somehow my calculator is going overboard today. Okay, so there's left bound. Any side on the left is fine. Press enter, get to the right bound. Okay, I'm on the right. Hit enter, it says to guess, press enter. So this, ladies and gentlemen, this gives us two important parts, okay? First of all, it tells us the maximum height, and it tells you when it occurs, okay? So we're going to go back to our lesson and say, therefore, max height of 264.49 meters at 7.35 seconds. Okay, and that's one of the important parts of a quadratic is the minimum or maximum value, or the vertex value. Okay? Next question says, at 10 seconds, what was the height of the rocket? Well, that's a value question, so we're going to go to the menu and press value. And although time equals 10 seconds, we have to let it be x for our graphing calculator. So we're going to sub in x equals 10 and then find out what y is. Okay, let's do that. So we go to our menu again, second trace. It's a value question. So that's number 1. Okay, and we're going to sub in 10. Okay, and when we're at 10 seconds, we are at 230 meters. Okay, so time means at 10 seconds, where am I? Goes across, and it calculates to 230 meters. Okay, so put that in here. Therefore, height is 230 meters at 10 seconds. Okay, next one. This is a little tricky one, but it's really cool once you see what we do here. Okay, when was the rocket at 200 meters? Well, first of all, we know that our maximum height is 264 meters, so we know it's gonna make it to it. However, we got to have some type of horizontal line here, and we sub in a height of 200 meters, and we're going to find not one point of intersection, but 2 points of intersection, ladies and gentlemen. Okay, and so what we're going to do first is go to y equals and go to y2 and enter in a height of 200, and then find point of intersection. So we're going to use the intersect button. Okay, if you haven't drawn that little graph up above, guys, just draw one here and show that, hey, here's my parabola, and show that you're going to enter a line in here at 200, and then you're going to find these 2 points of intersections, because it's going to be at 200 on the way up, it's going to go past it, and then it's going to get 200 on the way back. All right, let's do it. Okay, so I'm going to go to y equals. I'm going to clear my other stuff here first. Arrow down to y2. and just type in 200 and graph it to show that you've got that line there. And then we want to find these points of intersection. So let's find this red one first. Okay, so we go to the menu and go second to trace, intersect, which is 5. Okay, so to do the first curve, we've got to get the cursor on this side of the vertex, on the one to the left side. So anywhere there is fine. Okay, press enter. It's going to jump to the second curve. It says to guess. Okay, so notice my first intersection point is 350 or 372. So I'll just go type that in there quickly. So we have 3.72, that's the first one. And then I've got to go back and do the other one, because there's 2 of them now. Okay, so forget the red one now. I'm going to now go and find the blue one up here. All right, so I go second trace. Again, I want to intersect, which is 5. Got to get my cursor on the other side of the vertex so I know to get the other intersection point. So anywhere here, guys, is fine. Let's do a little bit closer. Okay, press enter, goes to the graph, guess, okay, and you get 10.97. Okay, so we had 2 answers there. One was 3.72, one was 10.97. Okay, so therefore the rocket is at 200 meters. Sorry, I forgot a T in rocket. When time is 3.72 seconds and also at 10.97 seconds. So on the way up it hits 200, goes past 200, and then on the way down it comes past 200. All right. Cool, so there's a good example of this one. Just remember, you might want to write a little note here. Enter in a horizontal line. And find points of intersection here. All right, cool. There's one example, 1 down, 2 to go. These ones will go a little faster, guys, okay, because we've already explained a lot of the stuff. Example 2, a rocket was shot giving the equation, and here's another quadratic, okay. And notice, folks, on this quadratic that's in standard form, you've got a number at the end. So what does that represent? That actually answers question A, but we'll go prove it, okay. That tells us that the rocket was shot at 3 meters. So instead of drawing it right at the origin, I'm going to start at 3, go up and come down. Okay? All right? And if this is my T, this is my H. Okay? So let's go back to my graphing calculator. Let's plug in that new equation. Okay? So go to y equals. I'm going to leave the negative 4.9 x squared there. I'm going to change it to 76. Don't forget that if you're doing it with me. And then we're going to go plus 3. Let's just go back for a second. Plus 3. Okay, I'm going to go to Y2 and clear it because I'm not going to use that. And I'm going to check to see if my window's still good. So let's press graph. And I can still see that my window's good. Notice here, folks, that it doesn't start right at the origin. It starts a little up higher. That should make sense. So let's prove that first one where it says, at what height did the rocket get shot? Again, the time is 0. So you're going to go to second trace, press your value button, which is 1. Enter in your time as 0. Okay, so at time 0, it says that the rocket was at 3. The great thing about noticing a quadratic in standard form is it tells you the initial height. Okay, so that's one thing to remember. That's why we have different forms of the quadratic, and the standard form, which this one is, tells us the initial startup value, or your y-intercept. Okay, so you could say y-intercept equals 3, or you could go to the value menu in your calculator and you could type in t or x equals 0 because t is replaced by x in the graphing calculator. So x equals 0, and you notice y equals 3. So therefore, shot at 3 meters. Okay? Next question, when did the rocket hit the ground? So folks, that's over here. Notice in this case, there's going to be another 0, folks, but it's going to be negative, and we're not going to worry about the -1, okay? We're always worried about the time when it comes back down. All right, so let's go back over to our graph. Go to our menu. It's a 0, so we're going to press 2. Again, you got to get that cursor over to the other side of the vertex. Come on. Keep going. Come on. Okay, now it's going crazy on me. It's sorry. It's deciding to hold it, which is funny because I'm not used to doing this. Okay, there we go. We're better now. So left side, press enter. Right side, you know you're on the right side when your y's are negative. Guess. Okay, so it's going to tell you that you're at 15.55 seconds. Let's go back and fill that in. Okay, so use the 0 menu. Okay, and you get the, so therefore rocket hits ground at 15.55 seconds. All right. Question. What was the maximum height of the rocket? How long did it take for the rocket to maximize its height? So we want to find out the vertex, which is here. And in this case, that's called a maximum. So we need to know what the maximum height is and the time it took to get to the maximum height. So we're going to press our maximum button. So I flip over, go second trace, maximum. Again, we've got to get to the left side of the vertex. Please don't. See if my graphing calculator will not jam on me this time. I think we're going to be okay if I just tap it gently here. Okay, so notice I'm on the left side. That's good. I press enter. Go to the right side. Press enter. It's going to say guess. Okay, so there's your maximum height of 297 meters and 0.69 meters, and the time it takes is 7.76 seconds. So let's put that in our note. Okay, so therefore, max height of 297.69 meters at 7.76 seconds. Okay? Moving on, at 10 seconds, what was the height of the rocket? So that's going to be a value question. So you go value, then you're going to sub in x equals 10 and find out what y equals. So let's do that. So we go over here, second trace, value, 10, and it says it's at 273. So we will say at 10 seconds, the rocket was at 273 meters. Okay, when was the rocket at 200 meters? So again, we are going to put in a horizontal line at 200 and determine the points of intersection. So we're going to go y2 equals 200. Okay, I'm going to press the intersect button. Okay, so let's just do those two at once. I think we can handle it now. Let's go to y equals, go down, put y2, put 200, graph it. Got that? Great. Now we're going to do the menu, go to intersect 5. Okay, since I'm over here, I'll find the second one first, since it's already here, so hit enter. Okay, so at 200 meters, we've got 12.22. Just make note of that, and we'll do the other one. Bring the cursor to the other side of the vertex, so you get the first point of intersection. Perfect. Anywhere over there is fine. Okay, so go enter, enter, and 3.29. So our two answers there, guys, were 3.29 3.29 seconds, and 12.22 seconds. Okay, to do a great little nice little therefore. So therefore, the rocket was at 200 meters when time was 3.29 seconds and at 12.22 seconds. Great. Last example, it's going to look a little different, so let's pay attention here. A cliff diver jumped, giving the equation negative 4.9 t squared plus 100. So this is a little different, okay? So because I know a little bit more about a cliff diver and about quadratics, is when you jump off a cliff, you are starting at your maximum height. So we're going to start here and we're going to shift and go down. Okay, so visualize, folks, this is half of a parabola. The other half is over here. Okay, so if I graph this, it's going to look a little odd, but we can do it. So let's go to y equals. I'm going to clear the second one, go up to the top one. I've got negative 4.9 t squared, and then I'm just going to change this to plus 100. Okay, I'm going to press graph. Okay, I'm going to fix my window because it doesn't look very good. So my window's going to go 0 for time, and I will say, I don't know, 8 seconds to drop. Let's just take a maximum height of 110. Let's see if that works. See if that looks better. There you go, guys. So there's that graph I was looking for. Okay, and now it says, at what height did the diver jump? So if I quickly go back, guys, to the equation, that's your y-intercept. You already know that it jumped at 100 meters. Okay, so you can say y-intercept equals 100. Or you can go value and say, hey, the time when he jumped was when x equals 0. So let's quickly do that, just to prove it. Okay, so we're going to go second trace, value, hit 0 for time, and hit enter, and it proves it right there, 100 meters. So go back and do that one. Okay, so therefore he started at 100 meters. Okay, when did the diver hit the ground? Again, we're looking for this y-intercept. That's a 0. Okay, so we'll press, go to the calculator, second trace, 0. Okay, and we're worried about this one over here, so just cursor over a bit. Okay, hit enter. Right bound, make sure you go negative for your y's. Okay, and you'll find 4.52 seconds. Okay, so here we go. Therefore, it takes 4.52 seconds to hit the water. Sorry, I think I said he hit the ground. I'm sorry. He hit the water. That's good. He's safe. Okay, what was the maximum height of the diver? Well, hey, we should know by theory that the maximum height is this. Okay, because that's where he starts it. Okay, however, let's go and try it. Okay, so to do the maximum height, we go second trace, maximum, which is 4. Okay, I have to actually shift over here to the left side. Even though it's not drawn here, you'll see that the x's will go negative here for me. Okay, so see how this is actually drawing it in for me, guys? Okay, all right, stop. See how it's... Okay, so there's my left bound. I hit enter. Right bound gets me on the other side again. Come on, calculator. See, if I hold on to it, it'll actually lock, and then I'll be in trouble here. So I have to go very gently. Okay, so I'm on the right side. I hit enter. And so the maximum height there is 100 meters. Okay, so you press the maximum, did your left, right. Okay, therefore max height of 100 meters. And I'm just going to put down in brackets at start. Because some quadratics start like that, okay? At 3 seconds, what was the height of the diver? So that's going to be a value question. And you enter in x equals 3. So let's go do that. We're almost done here, folks. Okay, I've got good news at the end here, so let's get through this. Okay, so second, trace, value, 3. And it says we are at 55.9 meters. Okay, so we are therefore 55.9 meters at 3 seconds. Okay, and when was the diver at 20 meters? Again, you've got to go enter in that 20 meter mark. So you got to go like this. So we're going to go y2 equals 20. Find the point of intersection. We're only going to worry about 1 this time because we only have a path of half of the parabola, right? So let's do that. So we're going to go y2 equals 20. Graph it. Okay, we're not going to worry about the negative intersection, so we're going to go to the positive one. All right, so we go second trace, intersect 5. Make sure on the left side of the vertex, guys, coming down here. Okay, anywhere here is fine. Okay, okay, press enter. Let's say second curve, guess, and you'll find your point of intersection there, folks. Oh, it actually found the negative one. So let's try that again. Second trace, intersection point. Let's bring it all the way over. And in. Sorry, my class is just coming in, so just give me a second here. Okay. So let's get closer to this point of intersection over here. There, now we're going to see it. That'll help me. Okay, now I press enter, guess. Okay, so the intersection point there is 4.04. So, going back to our note to finish off, therefore, diver is at 20 meters at 4.04 seconds. Okay, guys. Here is the great news for tonight. There is no homework, so enjoy. Hope you understood those 3 quadratics. If you're bored and you want to Google some of the interesting quadratics on the internet, feel free to do so. But if not, you can try these graphing calculators in class. If you have any questions at all, come see me. I'm here for help. Have a great day.